Bad timing. Hey guys, welcome back. Sorry, that was the bell. Hope you're doing well. Today's lesson is going to be trigonometry. And this is just going to be the intro of trigonometry. We're not going to dive into how to use it in terms of application problems and so forth. That will be in future lesson videos. Today is just like the basics of trigonometry. Okay, so let's go ahead and get into it. Trigonometry, if we break down the word itself, okay, comes from two Greek terms. So trigon, we're talking about triangles. Metron or metry talks about measurement. So literally it translates to triangle measurement, okay? If you go back to what geometry is, okay, if we break down that word, okay, geo means we're talking about earth, metry is measure, so earth measurement, okay? So using just the same principle of how we break down geometry, trigonometry can be broken down very similarly. Now, what is trigonometry? Okay, it's a great question, not one that can be wrapped up in a couple minutes, but here's the premise of it, okay? We're trying to figure out if there's a relationship between the angles of a triangle and its side lengths, okay? Now, trigonometry deals with primarily right triangles, okay? So when we think about trigonometry, you want to think about right triangles. Just like Pythagorean theorem only works for right triangles, okay? Now, later on, you'll actually start talking about triangles that aren't right triangles. That's like lost sines and cosines, but not going to be for our geometry class, okay? It's kind of going outside the scope. So look at these three triangles we drew up here on the board. Let's say I have angle A with the side lengths A, B, and C. Okay, now typically in trigonometry, the side lengths are the side lengths are labeled with lowercase letters, and the angles are uppercase letters. They also use Greek letters, okay, alpha, theta, phi, and so forth. We'll talk about those when we do some problem solving, okay, but for right now, we're going to keep it basic. Looking at all three of these, we could see that here's angle A, and here's what my normal triangle looks like right now. So this is my first starting point. And notice, if I make angle A larger, okay, see what happens? The side lengths start changing. And then if I make angle A smaller, my side lengths are starting to change again, okay? So we can see that there is some correlation between the angle and the side lengths, okay? There's some observation happening here. Now, what we can also do is compare the side lengths, okay? So we can compare, side lengths A and B here with side lengths A and B over here and down to here, okay? Notice how these are right triangles, and we could talk about similarities here too, which we'll do in the future. So I can see just from observation that there's some connection between an angle and its side lengths, and I can make some comparisons, okay? Now, when we make comparisons, especially when we talked about similarity, we talked about ratios, right? Ratios are those comparisons. So for instance, I could compare, if we just look at this triangle, I could compare the measurements A to B, or I could compare from A to C, or B to C, okay? But if you look at it, I need to have some sort of name to these guys. If I say, hey, compare side lengths this to this, that's okay, but it's nice to have a name for each ratio, okay? So that's what we're going to do today. The object of today's lesson is to pull up the possible ratios of this right triangle and put names to them, okay? So that's the first part of trigonometry, all right? And remember, we're making comparisons here. That's what this comes down to. All right, so each one of these ratios we call trigonometric ratios, okay? Sounds like such a sophisticated and fancy word. Trigonometric ratios are just you comparing two sides of a right triangle. Now, here come the names. Okay, here we go. So to determine which ratios we're looking at, we're going to use the names sine, okay, cosine, and tangent. All right, and actually, one second. Okay, let me write out the full word of it here. Sine, cosine, and tangent. Okay. We do abbreviate. So sine, we abbreviate SIN. Cosine, we could abbreviate COS. And tangent, we abbreviate with TAN. Okay? Because in mathematics, we hate to write. So why not just abbreviate things just a little bit, right? I mean, I honestly don't know. I just figured, why not? That seems like a good reason for it. Okay, less to write. So what we're going to try to do is figure out which one of these names goes with which one of these ratios. Okay? Now, when you pronounce these, you don't pronounce this as sin. You still say sine. Think of it this way. In English, okay, this means etc., right? ETC, but you don't say act. You just say the full word, etc. Okay? Same thing here. Cosine and then tangent. So just say the full pronunciation of it. I still hear people saying cos and tan. Here, my logic behind it is, like I just said here, you don't pronounce this as act. You say the word etc. So why would you say cos or tan? But I know out there, the general public, everyone does it. I think I might be the only one who doesn't quite agree with it, but hey, that's just me. All right? Okay, so now let's talk about those names and what side lengths go with them. Now notice, looking at this triangle, okay, I picked angle A as my point of reference, okay? And that's what you're going to do too. You're going to have an angle as a point of reference so you know what side lengths you want. Notice, I'm never going to pick the 90-degree angle side, okay? I could pick angle A or angle B here, but I'll never pick angle C. And more on that in a future video. Sine, starting with A, okay, the opposite side of angle A and the hypotenuse of the triangle, that ratio, we're going to name it sine, okay? So let's take a look at this. So here's angle A. Opposite means I'm going diagonal from angle A, and it's going to be this guy, okay? So that's going to be lowercase a. The hypotenuse of this right triangle, it's always diagonal from the right angle, and that's going to be C. Okay? So this ratio, we're going to name that sine. Next one. Angle A is still something we're using. And cosine says, hey, I want you to compare the sides that are adjacent and hypotenuse of this triangle. So let's go back to the diagram here. So here's angle A. Now, adjacent. What does that mean? Go back to your English classes, okay? Adjacent means next to, okay? So what side length is next to angle A? Well, it's going to be B. B's next to it, okay? And then, there we go. Then the hypotenuse is going to be C. Hypotenuse doesn't change. It's always going to be across the right angle. Now you're probably thinking, wait a minute. Wait. You said that adjacent was next to it. Isn't C next to it? It is. But C has a title. C's the hypotenuse. It can't be both when it comes to these ratios when we're naming them. Okay? Because if it was, then you have what? C over C. That's not really a comparison there. And then last one, tangent. The two side lengths that we call tangent are the opposite side and the adjacent side. Okay? So going back to the picture, angle A, opposite would be lowercase a, and then adjacent would be B. So A over B. Okay? So all three of these ratios have these specific names to it. All right? Hey, pretty cool, huh? I know, it seems weird. You haven't really talked about what's the usefulness of this yet. We're getting there, okay? Sorry, dropped my marker cap. But we're just naming, okay? Now, a good way to remember this, okay, this marker's done. And I didn't make the basket, okay. Oh well. I thought I made it in the trash bin. Okay. We can use this, SOHCAHTOA. This is a very helpful way to remember what side lengths or what ratios go with what name, okay? The first letter is the trig ratio name. So S stands for sine. The other two letters tell you the side lengths of that triangle that go with it. So sine always goes with opposite over hypotenuse. Cosine always goes with adjacent over hypotenuse. I'm going to abbreviate adjacent as ADJ, by the way. And then TOA, T is tangent, and that's opposite over the adjacent side. Okay? So once, I know I'm repeating myself just because this looks so foreign right now to us. But remember, I'm just coming up with a ratio of sides that we're comparing here. And then I'm naming each ratio specifically. Okay? That's it. All right. So let's go ahead and practice this a little bit. There we go. Okay, so here's an example. And what I'm going to do is rewrite this so we have a reference. In fact, let's there we go. I think I could put this into view. There we go. All right. So I won't need this then. So what I have is a triangle here. And what we're going to do is we're going to come up with the ratios for each one of these guys. Okay? Now, let me just adjust the camera just a little bit. That way you can see it better. All right. The first three problems deal with angle P. So just note that when you write a trig ratio, you write the ratio name and the angle that you're looking at. That's the perspective. Okay? So let's look at the first one. Okay, this is sine of P. So we're looking at this angle right here. Now here's a hint. This is what I would recommend. Across the right angle is the hypotenuse. All right? I'm going to label that. That way it's easier for me to see what sides are what. And that's going to make more sense when we go through these examples. All right, the first one, sine of P. Now, sine is what two measurements? It's the opposite over hypotenuse. Okay? So looking at angle P, what side's opposite? Well, if I go diagonally across, that's going to be 15. And then my hypotenuse is 17. So 15 over 17, that ratio, we call it sine. Okay? All right, cosine's next. So here we're right here still. Cosine is the adjacent side over hypotenuse. That's the ratio that goes with that name. So that's going to be 8, which is next to it, over 17. Remember, I know 17 is next to this, but it already has a title. It's the hypotenuse. Okay? Can't compare two things when they're the same thing. There's no comparison. And the last one, tangent. Okay? So tangent, if we look, is the opposite side over the adjacent side. So the opposite side is 15, and the adjacent side is 8. So 15 over 8 for that guy. Wait, so far so good? Now, I don't know if you noticed this, but tangent's the only one that doesn't have the hypotenuse. And if that's the case, the hypotenuse is the largest side, right? So that means when I divide these, it's going to be bigger than 1, huh? These guys will never be bigger than 1. So there's like a domain thing going on here, huh, when it comes to some trig functions. And I don't want to get too far into that right now, but just kind of make you think a little bit. All right, next we're going to switch up the angle. We're going to talk about angle Q. Erase that. I'm going to put an arrow right here. Okay, now sine of Q. What two side lengths go with it? So we'll start here at angle Q. Sine is the opposite over hypotenuse. Now what side's opposite of this angle? 8. And then 17 is my hypotenuse. There we go. Let's continue. Cosine of Q. So cosine is the adjacent side over hypotenuse. So here's angle Q. Adjacent would be next to it, that's 15, and the hypotenuse is 17. So it would be 15 over 17. And then finally, tangent is your opposite side over your adjacent side. Okay, so here's tangent. So opposite would be 8, adjacent would be 15. Okay. Now notice, this one will be less than 1, but as you can see, tangent might be the only thing that can go bigger than 1 when it comes to a fraction. Now make a comparison. Notice, depending on the angle you're looking at, the ratio itself is going to be a different number. So that's what it comes down to. When you're defining what sine, cosine, tangent are, you have to tell me what angle you're looking at. Okay? And remember, we will not be selecting R or whatever this angle is that's next to the 90-degree angle. We won't be selecting that guy. Okay? And And that's it. That's the intro to trigonometry. Now, my notes online do have other examples that you can practice naming these guys with their ratios, okay? But that's pretty much it. Just a naming lesson. Kind of weird, huh? But remember, trigonometry, it works with just right triangles. That's it. Doesn't work for any other triangle. And we're just making comparisons, okay? And what we're going to see in like future videos is that the angle measurement makes these changes and how the angle measurement can be related to the side lengths. So we'll get to that soon. All right? Hope you're all doing well, and I will see you all in the next lesson video. Thank you.